So to make m the subject of this formula, we need to multiply both sides by m minus 2, because then this division of 2 will cancel with a multiplication of 2. So now we have v multiplied by m minus 2 is equal to m. And now we need to multiply out this bracket. So we'll multiply the v by the m to get vm, and the v by the negative 2 to get minus 2v. And again, this is equal to m. So now I'm going to move the negative 2v's to the right-hand side by adding 2v to both sides. And this negative 2v will cancel with positive 2v to make 0. So now we have vm is equal to m plus 2v. Now we'll move this positive m to the left-hand side by taking away m from both. These will cancel, so we have vm minus m is equal to 2v. Now we'll factorize out the m on the left-hand side, so we have m lots of v minus 1 is equal to 2v, and we'll divide both sides by v minus 1. And again, this multiplication and division will cancel, so we're left with m is equal to 2v over v minus 1. So we've been told that m is proportional to p cubed. And this symbol here means in proportion to. So now we need to use the constant of proportionality k, and this will tell us how they're in proportion. So m is equal to k times p cubed. So to work out the value of k, we're told in the question that p is equal to 2 when m is equal to 160. So we can substitute these two values back into the equation above. So m, 160, is equal to k multiplied by 2 to the power of 3. So k is equal to 160 divided by 8, which is 20. So now we can put this 20 in place of k. This will give us m is equal to 20 p cubed. And we can use this equation now to work out m when p equals 3. So we'll say that m is equal to 20 multiplied by 3, which is p cubed. So m is equal to 20 multiplied by 27. M is equal to 540. So 5 to the 0, well, anything to the power of 0 is always 1. So 5 to the 0 is equal to 1. For question B, 49 to the power of a half, well, we can write this as the square root of 49 all to the power of 1. So this denominator of 2 is the root, and this 1 is we're raising this to a power of 1. So we're looking at the square root of 49, which is 7. And for question C, this negative power means we have a reciprocal of this base. And the reciprocal means we just flip it upside down. So 8 over 27, which is now raised to a power of 2/3. And just like we did with question B, we can write this as 8 to the 3rd root squared divided by 27 to the 3rd root of a cube root, again squared. The cube root of 8 is 2, and 2 squared is 4. And the cube root of 27 is 3, and 3 squared is 9. So this is 4/9. So we've been asked to write this fraction in the form a plus b root 3. So we'll begin by multiplying the numerator and denominator by root 3. So this becomes root 3 lots of 6 minus root 12 all over root 3 squared, which is root 3 times by itself. So the reason why we multiplied it by root 3 is because this square root and the squared will cancel, which will make the denominator rational. And we do the same for the numerator, because this then becomes 1. When we times this by 1, we don't change its value. This becomes root 3 times 6, 6 root 3, and then root 3 times negative root 12, which is minus root 36, all over, and the square root and the square will cancel, so it's over 3. We can simplify the square root of 36, so we have 6 root 3 minus 6 all over 3. Now we can factorize that with 3 in the numerator, so we have 3 lots of 2 root 3 minus 2 all over 3, and these will cancel. So this becomes 2 root 3 minus 2. And in the form a plus b root 3, it's negative 2 plus 2 root 3. So your a is negative 2, and your b is positive 2. We've been asked to show that x squared minus 4x minus 12 equals 0. So to do this, we're going to apply Pythagoras' theorem to this right angle triangle. So this means we have the x squared plus the x plus 2 squared will equal the square on the side of our hypotenuse, which is x plus 4 squared. We can expand all the brackets, so we get x squared plus x squared plus 4x plus 4, which is this expanded, equals x squared plus 8x plus 16, which is the square of x plus 4. Now we can move the x squared, the 8x, and the positive 16 to the other side by taking them away. So we get x squared minus 4x minus 12 equals 0. So now to work out the area of a triangle, we need to solve this equation, which we can do by factorizing. So we get x minus 2 and x plus 6 equals 0, which gives us solutions of x equals positive 2 and x equals negative 6. We know x is a length, so this cannot be a valid solution. So x is equal to 2. So now we've got our triangle with a base of 4, a height of 2, so an area of 4 centimeters squared. We've been asked to work out this angle here. So we need to apply various circle theorems. The first one we're going to apply is to work out this angle. And we can see that angle ADB and ACB are equal because we've got angles that have a circumference in the same segment. Angle C is also 32. And we'll just make a note of Y here. So now, if we know this is 14, we can apply the same idea to work out this angle. Again, angles that have a circumference of the same segment. DAC is also equal to 14 degrees. And if we know these two, we can also work out this angle, which will be 134, because we have angles in a triangle. So now we can work out this angle, AEB, using angles on a straight line. So AEB will be 46 degrees. And because this is an isosceles triangle, we know this one will be 180 take away this one divided by 2, which is 67 degrees. And we can say that 67 because base angles are equal in an isosceles triangle. To show triangle ADC is congruent to triangle BDC, we're going to use side, side, and side. So we've been told that ABC, this triangle, is isosceles, which means that this side, AC, is equal to CB. So we'll write that AC is equal to CB because it is given as an isosceles triangle. And we can see that CD is common to both, so therefore must be equal in both. And finally, AD we can work out using Pythagorean theorem. And because this side and this side we've proven it's the same as this side and this side, these two must both be equal because this is also a right angle. Therefore, side, side, side proves triangle ADC is congruent to triangle DBC. In a frequency diagram, the frequency is measured by the area of the bar rather than its height. Its height is measured by frequency density, and this is the frequency divided by the class width. So we can see in the range of 30 to 50, which is from here to here, we have an area of 20 multiplied by 4.2. So your frequency of 20 multiplied by 4.2 is 84. We can use the same idea with the next bar between 50 to 60. So this will be 10 multiplied by the frequency density of 6. So this gives us a frequency of 60. And to show this in our histogram, we go from 60 to 80 to a frequency of 40. So our frequency density will be 40 divided by 20, which is 2. So we go up to 2 within that range. And finally, the frequency density between 80 to 110 will be 18 divided by the class width of 30. So this will be up to 0.6, which is about here.